In this video, we give an introduction to the autoregressive distributed lag model, the ADL model. We consider the stationarity condition, and we discuss the dynamic multipliers. We consider the simple ADL 1-1 model, which is given by yt equal to a constant term plus theta yt minus 1 plus phi 0 xt plus phi 1 xt minus 1. Finally, we have residual and error term epsilon t. So note that we have our autoregressive component, the lag of yt, and then we have xt at point t in time, as well as with a lag. We make the usual assumptions. We state that t goes from 1 all the way up to capital T, so that's our sample size. We assume that the initial value y0 is given. And finally, we make either the assumption that epsilon t is IID with mean 0 and variance sigma square, or we make the assumption that the expected value of epsilon t given yt minus 1 xt and xt minus 1 is equal to 0. We can use the first distributional assumption to derive maximum likelihood estimator, or we can use this to derive our method of moments estimator. Note that the assumption here rules out feedback from yt to xt, so it implies that there's no feedback from yt to xt. So at the same point in time, yt cannot influence xt back. Should also be noted that we have assumed a linear relationship here. We have modeled the conditional expectation of y given its own past, and given the entire sample of x up until point t in time. That is given by the model here, delta plus theta yt minus 1 plus phi 0 xt plus phi 1 xt minus 1. So the model represents a conditional expectation of yt given its own past and given xt up until point t in time. Stationarity of yt requires two things. First, we need xt to be stationary. So we are conditioning on xt, and if that is stationary, yt is also stationary, provided that the autoregressive polynomial is invertible. In our case here, that means that the absolute value of the parameter theta must be smaller than 1. So note that this is just our usual stationarity condition for an AR1 process, and we need that in addition to xt being stationary, and then yt is stationary. Another way of stating this is that the inverse characteristic roots all fall inside the unit circle. Now the next thing we will consider, that's the dynamic multipliers. So we are interested in the effect of a shock to xt on yt plus 1, and so on. And note here that we could rewrite the model, so we could write it out for t. We have the equation from before. We could do the same for t plus 1. And we could do it for t plus 2. Like this. So the first dynamic multiplier, that's the effect on yt of a shock to xt. And we note that from the equation over here, there's a direct effect with a coefficient of phi 0. So that's the first dynamic multiplier if we have a shock in xt. So a shock to xt will have an impact on yt in the same period with a size of phi 0. If we look at the next period, the effect of a shock to xt on yt plus 1. And note now that there are two effects coming in. There's a direct effect here, and then there's an indirect effect going through xt, having an impact on yt, which next period influences yt plus 1. We can rewrite this as the derivative of yt given xt minus 1 And then we get first an indirect effect, which is just theta, the derivative of yt given xt, plus the direct effect coming from here, which is coefficient of phi 1. If we multiply these together, we get theta phi 0 plus phi 1. Now we could do the effect on t plus 2 given a change in xt, a shock to xt, and that's the same as the derivative of yt given xt minus 2. And we note here that there's no direct effect, there's only the indirect effect, so what we get is theta multiplied by the derivative of yt plus 1 with respect to xt, and this we have an expression for already, so this is equal to theta multiplied by theta phi 0 plus phi 1. Now finally we could do this for yt plus k with respect to xt, and we note that this formula here we just iterated forward one period, and we get theta to the power of k minus 1 multiplied by theta phi 0 plus phi 1. Finally note that if theta is numerically smaller than 1, then theta to the power of k minus 1 will converge to 0, so the dynamic multiplier here converges to 0 as k goes to infinity. So this says that the shocks to xt only have a transitory effect on yt. Yt plus 1 and so on. So the dynamic multipliers here converge to 0 as k goes to infinity. So that's all for now. Thanks for watching.